Hi guys, so I'm here with another interesting topic actually. The topic is base conversion. Recently I was studying a problem solving book, then I studied those base conversion stuffs, and I figured it out. How can we do that in code? Like, I'm doing computer programming, right? So to apply that, I need to know how to do it in code. To do that in code, so I try to figure out how to do it. Like, I have a base 10 number, suppose x, and the base I want to convert it to, which is b. So how can I do it? That's the interesting thing here. How can I do it? So let's check here. This was my rep preparation. Sorry for that. So basically what we'll do suppose we have a number called 59 and we want to turn that 59 into base 5. So what we will do here is we will keep the number. Sorry for the issues. I think something is wrong on my graphics tablet. Wait, yeah. I guess now it's fine. Yeah, it's some driver issues, you know. So what we want to do it here, okay? So we want to convert it like lowest significant bit to maximum significant bit. What we need to do here. So we want to do it in. We want to convert it. Like, there is no such C++ functions that can convert a number to base 10 to base n, or base n to base 10. We'll study the base n to base 10 later. That base n to base 10 requires 10 to the power 6, 10 to the power 10 to the power n to multiply, but it requires power function, and power function is not good for efficiency, you know. So let's try our base 10 to n actually. Let's try it. So here we can look here. If we start to divide 5, what we get is that, okay, what we get 5, 5, 1, 5, so we get 11, and 11 are 4. Here R4 means a reminder. That's what I'm trying to do here. And then so now I got 11. Now I divide 11 by 5, which is, how would it be? Yeah, it's gonna be 2. Reminder is 1. And then 2 divided by 5, 0. Are what? 2. So what we get is that 2, we will progress it from here. We will write our number from the arrow direction I wrote. Okay, the arrow direction I wrote. Remember that. Okay, remember that the arrow direction I wrote. So be very careful of that. The arrow direction I wrote, 214. Now what I'm claiming is that the number will be 214, and is this true? Let's check it. We have a number 214, and we want to convert it into 5. No, sorry, we have 59. We actually converted 59, right? Let's convert 59. So calculate 214. See, 12, and they did the same process here. The same process they did here. So now, how can we do that thing in code? So it's an interesting fact, right? Now we'll now check that in code in C++. My purpose is for competitive programming, and I'm just doing these videos for fun, like not for really good stuff issues, or like, you know, for fun. Nothing serious. If you see any mistakes, please let me know in the comment section. I would love to know. So let's write the code. Suppose we want to write a number 59 out of 59. No, let's take a number like 247. 147, okay, 147. And we will convert it to 8 base. Okay, so we will take the input value here. And okay. So and now we'll add a string. Why will we use a string? Look at here. I want to add the numbers, right? I want to add the numbers here like this way. Now the interesting fact is, if I use vector arrays, the numbers won't be like that. They will be in a space situation. So whenever you wanna, suppose you wanna print a number and you found all the digits, try to print those numbers in a string, because in string, no matter what you add, it will treat it as a character, like as an, like here the 1 is an alphabet for the string. It will just add it. So that's how it's gonna go. So we use the string. I will teach you how it works. Now, when does the loop stop? Yeah, when does the loop stop? The loop stops. Why? Well, this is a. We will use a loop here. Let's use a while loop here. Suppose we're gonna use a while loop here, and this while loop will stop when we divide the number. The result is, I mean, the quotient of the quotient. When the quotient becomes 0, we will stop the loop. And now, how will we do it? It's the most interesting fact. How will we do it? We want to add the reminders. How will we do it? And also, we want to add those integers as strings. We'll learn a lot of stuff here. Check it out. Here, loop stops, and is greater than, the loop keeps going when n is greater than 0. And now we'll use this for an integer x, which calculates n by b, and string s. We know string s, right? It will add to x. You see that here? Now the thing is that we want to set the value of n, right? Like it becomes 11, then becomes 2. We want to change the quotient value until the quotient becomes 0. How will we do that? We will use our 59 number here. We will use our 59 number. How? Check it out. So look at this here. I write n equals to n by b. What this actually does, it will, number will go and the number will turn into the quotient of the number. When the number turns into the quotient, it will go back here again and then come back here again, right? This is how it will go. We'll simulate, no worries. This is how we'll go and we'll come easily. Now, there's another fact here. And you will answer, what's the fact? We are adding the integers as strings, right? But there's a catch here. We're adding it when we're adding the string. When we are adding the integers in the string, number will, if we print right now, if we print cout as like 1241, right? Well, we did 59.5, so let's do it here. 59 and then 5. See what happens. 412, but we want a 214. So it's a problem, right? So what we need to do is to reverse the array. Using a reverse function, you can use a reverse function here, or you can use the sort function, writing rbegin.rend. You can do that. So what we're going to do here is actually reverse s.begin s.end. Now what we will get is, and now we will see what will we get. 214. See, we got 214. So that's how we change a number to another base in coding. In this thing, right? I think these things will be sometimes in like a problems, or like divisional 4 problems. Sometimes these things might appear. And I'm still learning, I'm still a newbie in code forces. And I don't know that much. But what I'm trying to do in this YouTube channel, my purpose is that for the Feynman method, like if you want to be good at something, you need to teach that to someone else. So that's what I'm doing here right now. I learned that thing today. Now I'm teaching it to you. Maybe I might have faults and mistakes. It's okay, but I will be cautious about that, and your feedback will be important for me. So yeah, that's the main purpose here actually. So I hope you got the thing here. Now what do we have? We wrote 147, right? We wrote 147 and 8. We got 2 to 3. Let's see if it is true or not. 147. 2 to 3. We got that. Now I'm gonna see interesting. Is there something exists called one base number? Does it? No. There is no such thing exists such as one base numbers. We need to know that. Okay, thank you guys. It was very fun talking to you guys, and I hope you like this video. And yeah, see ya later. Bye bye.